Well, we've seen him before. Not that we're tired of him, because he always brings us some amazing information. It's Mr. Liviu Chircu.
Chircu, come on. We can do it, Alex.
I can't make that sound with my mouth. I'm sorry.
No, it was good. It was good.
It's easy.
Kill you, Chircu. Kill you, Chircu. There we go.
Good.
No circus. He's a very serious man. No circus.
Mr. Kill You is going to be talking about quality-based routing in OpenSIPS 3.1. So watch out, duck. You don't know what he'll be throwing at you. Liviu, take it away.
Thanks for the introduction, Alex. And as Alex was saying, this is I'm not sure whether he was saying it or not, but anyway, this is a new module that we introduced in 3.1. And the story goes back actually a few years ago, where we had an intern working for us for like almost 4 months, and he had a lot of fun with this module and spent like maybe half of his time working on fiddling with it, getting feedback from us, and he put it together. But unfortunately, we didn't feel like the time was right for it, nor did we get any traction. So we kind of kept it into the cupboard for like little over 4 years. But this year we finally decided to dust it off and brush it up a bit. And there we go. This is what I'm going to be talking about today. If you don't know me,
what else is in that cupboard at the end of this presentation?
Maybe an OpenSIPS 2020 t-shirt. I'm not sure. Does that answer your question?
I
hope so.
Fully informed. Thank you.
Good. If you don't know me yet, I've been privileged to be with the OpenSIPS project and the ecosystem around it, and all of these amazing people that contribute and give us feedback for roughly 8 years now. And those are some handles you can use to reach out to me or follow with updates that I periodically bring from the project. And in the presentation, and it looks like my voice is cracking again, like yesterday, we are going to talk about I'm going to make a short intro on the dynamic routing module in OpenSIPS. And to those of you who are not familiar, I think it will be a great help, especially given that the quality routing extension absolutely works on top of it. So it's helpful that we have a baseline of understanding. After which, I'm going to go into how the statistics work for queue routing. How do we rate the gateways? What kind of balancing algorithms we have over there? And towards the end, there will be a fun demo. It will be interactive, and hopefully things will go well, because you never know with these kind of things, all hell can break loose, right? It can break in lots of points. So about derouting, I guess I could say a few words about its history, but I haven't researched it. It just came up. I believe it was introduced by Bogdan, but maybe I wouldn't want to give like bad information, around 2008 or something like that. So it's quite old. However, it's super powerful and has been one of the most appreciated and used OpenSIPS modules across the years. Basically, there are three core concepts there are three important concepts to it that I'm going to discuss about. First, we have the gateways, because the purpose of this module is to simply route traffic and according to what you instructed to do. And the obvious question is where to route it to, obviously to SIP gateways. And here we have an example of 3 gateways that we are going to provision into the DR gateways table. Kind of, let me put up the pointer. It's important to assign each gateway its unique ID. And here we are going to play with a gateway from a company called LOLSIP and Funcom, and the Funcom carrier, which has 2 gateways. So the discussion for derouting is going to revolve around the idea of sending our traffic or routing our prefixes to these gateways. The second concept is the carrier, which is nothing more than a grouping of gateways. We have here the Funcom carrier, which I've labeled FC, and a couple of gateways that are going to be receiving the traffic in order. So if we put, I guess this also, by default, they are used in their given order. So in this case, the first one will receive all of the traffic, and eventually, if there are any issues, for example, you get kind of error replies, the traffic will fall back to the second one. These are the algorithms that you can use. Up until now, there were either use the given order, or you could use a weight-based balancing algorithm, which I'm going to talk about in a bit. And in 3.1, we introduced, as I was saying, that the queue routing is an extension for derouting, the quality-based balancing logic. So here is an example of, anyways, sorry. The third concept are the rules. So now that we have the destinations to send our traffic to, all we have to do is decide where to route each prefix. And a useful thing to mention here, or something that I overlooked, is that we had from the beginning, we had like a certain quality of these gateways. In this case, LOLSIP was a poor gateway, or kind of, we can use it as a backup, let's say, but not ideal. Whereas Funcom is the preferred player to route the traffic to. So in our example, if we have some prefixes that we want to ensure a certain baseline of quality, we would not even fail over to LS1, I guess. So we can use this kind of routing. Only send to Funcom, and otherwise don't send any traffic at all. For the and this is 44. I don't know, maybe the UK people are a bit picky, so they don't want bad media. For all other prefixes, we don't mind receiving poor media quality. So if we fail over to LS1, we'll take it. We'll happily take that. And of course, for the last routing rule, we have a Houston, Texas number, which is obviously Alex's number, and we will route it straight through LS1. So such that Alex receives less calls, since he's a busy man and he doesn't want people to bother him. We'll route all the people who want to reach Alex through the back gateway, so they hang up as soon as possible. And that pretty much sums up the prefix routing. So how we build our LCR, our least cost routing. Of course, as an operator, you will have a lot more information available, for example, which is the gateway that costs the least amount. And you can build these gateway lists to your exact preference. So you can maximize the amount of revenue, or in our case, and for today's module, we are maximizing the quality of the media. Here's an example of using the weight-based balancing algorithm. So if you look here, each identifier is assigned a weight, and the traffic will no longer have a kind of a fallback behavior. Rather, 75% of it will go to Funcom, and 1% will go to LOLSIP. This is an example of specifying the weights within a rule. But there's a next level to it as well. You can specify the weights within a carrier. So in our example, okay, 75% of the traffic goes to Funcom, but within Funcom, which has 2 gateways, we can ship 90% of the traffic to the second gateway, to Funcom 2, and 10% to Funcom 1. And I guess that's as complex as derouting gets. If all of this made sense up until now, you're pretty much 80% done with the module, and you've comprehended it. Congratulations. Of course, within a carrier, you can also sort the gateways via using quality-based algorithm, and we'll shortly get to that. So to sum up the derouting, it's a very powerful engine to build least cost routing rules. All of the prefixes are cached in RAM. This will speed up the lookups hugely compared to a disk lookup. As a fun fact, if you didn't know this, RAM is how much faster than the disk is RAM, Alex? I will tell you. Or
why, Alex? I can't tell you.
I know you know, but I want to see Alex if he knows it.
Twice as fast?
Twice as fast? Add up.
Something more.
That's a very fast disk. Send me a few of those.
It's freaking faster. You don't need to know why. It's just faster.
So RAM is 1,000,000 times faster than a hard disk drive, a memory-based one. Sorry, a magnetic hard drive.
Yeah, not an SSD one.
Yeah, of course.
Probably a little bit closer, but yeah.
Right. So the fact that all prefixes stay there, and a lot of them, OpenSIPS can take a lot of them, especially if you give it like 8 GB of shared memory, everything will fit. By the way, don't forget that you will have to use 2 times RAM, because during a reload, both data trees are still available. So there's that. We have constant prefix lookup times. This is important. And during a data reload, the traffic keeps on routing. Again, very helpful to know. So let's see the quality-based algorithm. And this is the guy who wrote it initially. This is Mihai. He's smiling back at us as well. I'm not sure. Yeah, I don't think I remember where he ended up. Probably at Google. Who knows?
If his code was in the cabinet, he's probably in a hole 6 feet under.
Yeah.
Knowing Bogan, yes.
Right. And here are the statistics the default statistics that the module uses in order to assess the quality of the SIP traffic. You have the average call duration, the average seizure ratio. If you don't know about this statistic, so the first one is pretty obvious, right? How many seconds a call lasts for. The seizure ratio counts how often are my calls getting answered. This is quite important because it means that if your ASR goes down, you're probably dealing with some kind of failure on your network at whatever level.
Just as quick correction, I think ASR is technically answer to seizure ratio, but yeah.
It sometimes can represent what Liviu said.
Yeah, but it's the same thing, but it's just...
Yes, seizure is the total of calls, right? Total. And it's...
seizure is
answer to seizure. So you take...
answer seizure rate.
Answers calls and divided by seizure, number of seizures.
The correct is answer seizure ratio. And even CCR, I remember in the past I was using...
Oh, yes, there's a typo in there, sorry. Answer. Yes.
And call completion ratio is often called also NER, network effectiveness ratio. So it's something that I learned because I remember these names. I think I provided some input on this a few years ago.
Interesting.
So you're saying it's been 2 years and Liviu just corrected it?
No, it's been answer seizure ratio all this time. It's okay. And I think we computed correctly because we take the answered calls and divide them by the total calls. Isn't that a seizure? So
Yes, it is. Anytime you figure the phone,
anytime you make a call, it's a seizure. Yeah, whether it completes or not.
All the others.
Yeah. Yeah, exactly. It's simple. But what I'm not 100% sure about is that CCR indeed. It's because I've looked at the code and it's kind of it's always bigger than the ASR. Let me grab the cursor again. So it's always larger than the ASR because it not only includes the 200 OK, but also the 400s, if I'm not mistaken, or the 5 or 6.
408, the unanswered, busy, and cancel. The ones that it's not your fault.
Then the code, yeah, we need to change that function a bit. But anyway, at least we have the general concept that it's it measures some kind of replies, or they're based on their SIP code, and we can add them up however the proper way to do it is, I guess. Do you have any other comments to make here, guys, on the stats, or I guess I should wrap them up. The average setup time is how many seconds? Sorry if I'm not being accurate here on the stats. I'm not sure if I recall it, whether if it's in seconds or milliseconds, but generally how long it takes to answer a call, and the PDD, how long it takes until you get something back, a ringing tone, or maybe even a rejection, I guess. Okay, so Flavia just posted the CCR. So it's 200s plus 408, 406, and 487 canceled. So a bit, so it's a superset. It's a superset of the answer seizure ratio. Okay. And the next question would be, how does the module collect these statistics? Because maybe it wouldn't be completely correct to collect them for a gateway, right, on all the routing. And the way we ended up, or the module ended up being designed, is that it collects them per prefix per gateway. And this allows you to detect maybe certain failures that are happening on some regions. For example, maybe calls to some specific country are receiving some bad stats, or anything down this line. So the module is keeping track of these pairs. Now the next question would be, how long does it keep track of these things for? And there are two configuration parameters available. There's the history span, which is given in minutes and simply says how long a given stat has left before it will expire. And there's the frequency of the sampling, or the sampling interval. And in this example, every 5 seconds, there will be the samples will basically be rotated. You can also view it as the rotation interval, right? Every 5 seconds, a set of statistics gets thrown away, while a new one gets inserted as time flows to the right. And also, and this is an awesome, how should I put it? An awesome way that open source development can work sometimes. This feature we actually received after feedback, after the initial round of discussions on the module. And if I'm not mistaken, let me see if I remember, I think Sebastian Sastre suggested, guys, we would like to see from this module the ability to route based on the media quality, or maybe the R factor, or some other stats that we may want to be able to customize into the module. And this materialized into this extra stats module parameter. And this is the syntax. Here we define the MOS, which is, if you're not familiar with MOS, I read a bit about it, so I'm not that familiar either, but at least I can tell you what it is. It's the mean opinion score of a gateway. From what I've read, that's what I'm saying, that I haven't worked with it, but it can, while it's meant to be a human opinion of a score, and it ranges from 1 to 5, where 1 is the worst score and 5 is the best, it can also be computed. So for maybe you are taking a sample of, while having the initial sample of, let's say, the best quality file, you play it through the gateway and you capture what it gives back, and then you compare the two files. And that percentage of similarity will give you the MOS, how similar is the replay of the media. Right, and the R factor, there's a bunch of ITUT documents on what it is. It's a number ranging from 50 to 100 or something like that, and it also shows the quality of that gateway. And here there are two interesting attachments you can make to a statistic. First, there's its direction, and you can use a plus or a minus in front of it. The default is plus, and it means whether you prefer it to be higher or lower. Even in our initial sample, if you haven't noticed, all operators would prefer to have as big of an ACD as possible, whereas keeping an as low of a PDD as possible. So when defining your thresholds, you have to tell OpenSIPS, okay, how do I interpret that threshold? Is it an upper or a lower threshold? Okay, and towards the right, you can also attach a custom value for the minimum amount of samples that are required for the statistic. Of course, some of them may fluctuate during live traffic, and you may want to accumulate maybe 20 or 30, maybe even 60 before saying, okay, I want to punish this gateway, or yeah, stuff like that. Okay, so we have this, we have the base statistics, we have the custom ones we can define. What do we do next? Oh yes, and here is the script function that you can use to set these things. Because as I was saying, these are your turf. You have to fetch the data, you have to provide OpenSIPS with the MOS. For example, maybe you compute it from RTP engine, and you get it back in the script, and you set it via these extra QR set extra stat function. These are the input parameters. It's the database ID of the rule and the name of the gateway that you want to set the stat for. Remember that it's a pair, right? So we're setting not just for the gateway, we're setting that MOS, but also for the prefix. So the first one gives you the rule, the routing rule. Right. So once we have this, the next question is, how do I tell the module what is right and what is wrong? And for this, we came up with the Q-routing profiles table. And this answers a couple questions. Like I said, what is exceeded and what is not, and by how much, because there are two levels of thresholds, let's say. And also what happens on each threshold, right? How does that change the traffic? And here is how it looks. Let's say we have, this is a graph for ACD. Let's say a normal value is like 2.5 minutes. And for some reason, after 20, it dips below, and not only below critical, but also, sorry, not below warning, but also below critical. So this is in the 15-second range. So probably there's some media issue going on. People aren't receiving media. That's why they are hanging up quickly, such that the average call duration of the platform has gone down so much. It signifies a critical problem here. And this is the moment in time that the gateway will probably be taken out of service. And of course, the traffic should come back to normal afterwards because it's not being used for routing anymore. And also there's what penalties do we use? This information is also included in the profile. And as I said, each statistics has 3 levels. There's a normal level where all the traffic is being sent to the gateway. And we came up with this. These are default values, of course. You can change them in the table as you wish. But we thought that maybe as a warning level, you could give it maybe half of the traffic. And if it dips below critical, okay, that gateway should not receive more than 5% of the traffic. Maybe because, of course, we have to keep on learning about its media quality. We cannot just take it out and risk, the time passing by, 60, what was that? 60 minutes. So an hour passes by, and then the stats rotate, and then the gateway is all of a sudden healthy again. So, and then more problems. So to prevent that, we just, as a proof of concept, we went with this penalty idea, such that we keep on getting feedback from the gateway. Maybe it recovers, who knows? Maybe it starts behaving well, and then the module will give it gradually more and more traffic back. And of course, once we computed these penalties for each statistics, we just multiply them together and obtain the final weight. In our case, let's say the gateway was behaving poorly with regards to answered calls, and it's kind of slow. Users get a kind of a latency before they get feedback. The PDD is down, such that the result of multiplying all of these together is a 0.25 weight. Of course, you can also set like an event for when these kind of things happen, so you can take whatever decision you may see fit. By default, this is off, but you can define this event bad destination threshold to your preferred value, such that the event queue routing bad destination is delivered via whatever mechanism you may please. Nowadays, I think there are like 6 ways for you to receive events from OpenSIPS, just to name a few. RabbitMQ, maybe via Datagram, maybe via plain TCP. There's a lot. And the event will contain the prefix and rule pair that suddenly do not behave well anymore. And as far as the weights go, the last question would be, okay, so we are computing these weights for each gateway. What do we do with them? What kind of algorithm do we choose? And we chose a couple of algorithms. Actually, there was an initial one, and then we reworked it into something that we thought should be the default value, the default one. And the default one ended up being dynamic weights. So basically what we've been talking throughout the presentation, in this case, since the bottom gateway is 4 times, has a 4 times larger weight than the other one, it receives 80% of the traffic, whereas LOLSIP only receives 1/5 of the traffic because they have poor media quality. Of course, the same thing happens if you are routing to a carrier, so grouped gateways here, the same behavior. And if a carrier has multiple gateways, the traffic is simply equally spread to them, if my memory serves me right. And this is a difference if you would have had 3 gateways. Because if we would have this scenario, whereas the other 2 ones aren't grouped, you can see that these received a bit more traffic. So if I go back to the other slide, here we had 20, 40, 40. And now with 3 individual gateways, there's this kind of spread. Just basic math, I guess, but it's kind of useful to note. Right. And the other algorithm is the one that we, you can use it if it works better for you. The gateways are simply sorted based on those ratings, and OpenSIPS uses them as a failover kind of in a failover kind of way. And this has, of course, there are some disadvantages to this approach. For example, in this case, only the first gateway is receiving the traffic, and the other ones are not being used. So maybe if you wanted to go for a more balanced approach, that doesn't happen in this case. And there's also that problem of if a problem happens on the first gateway, of course it will be taken to the back of the list. But as soon as the stats expire or they grow old on that, and it will be taken to the top of the list, and the problem will resurface. So you have this cycle of penalizing a gateway and then promoting it back. So this might happen with this type of approach. But again, it might also be exactly what some of you want. So that's why we kept the algorithm in there.
There is solutions for that.
Yeah, exactly.
We'll talk later.
Okay. It's nice to keep things flexible and give users some choice. So these are some resources. There are a couple of blogs on the quality-based routing, and of course the module documentation that you can use in order to build this kind of proof of concept and play with the module and the routing. And for the demo today, we are going to perform audience-driven routing. What this means is that I've prepared, we are going to be using an OpenSIPS to equally ship traffic both to LOLSIP and Funcom. So by default, it's 50-50. And you will log into this portal here. And I will kindly ask you to do so. And we will downvote LOLSIP because they are so bad that we want to alter the traffic live and punish them using, of course, the custom module statistics that I talked about earlier. We are basically... Sure.
One second, just to make the people's life easier. Can you simply copy paste the portal,
right,
and put it somewhere? We
sure.
can distribute it, but typing it from the slide, it's not exactly
sure
easy.
Okay.
Or just place it anywhere
on the summit. It's in the summit chat. Right now, it's not doing anything because the OpenSIPS is turned off. But I will show you the screen. So I put it on the summit, and I've noticed that if you put links on YouTube, they kind of delete them for you. I'm not sure. Maybe it's illegal to put links on YouTube. I'll put it there again, but I'm pretty sure.
You need approval from channel admin.
Channel admin. I see. Okay, so
that would be me, but I don't know. I have not seen your links. So, yeah.
Okay.
I pasted on YouTube. So it's there.
Okay. Right. So I hope you all got this. What should I show you? I guess I'm going to go and show the screen. Present the entire screen. And go to this desktop. Can you see the website here, the curating demo? On the left side, or is it a desktop problem? I have multiple.
Yes, we can.
It works. Perfect. Awesome. Okay. So this is all running on my local computer, and with the awesome help of Dan Jenkins, he reminded me of this ngrok.io service, which basically gives you a public address on their domain that points back to your private web server. So if you can see, people are already starting to play with it. And let's take a look at the OpenSIPS configuration file because there's quite a bit of time left. routing demo. Is this big enough of a font? Should I make it bigger?
It's good.
It's okay.
It's good. Okay. And it's a very simple script. We are basically, I mean, not that very simple, but I'm going to walk you through it. Within an infinite loop, we are just going to do a hell of a lot of do routings. And if you remember the slide, this thing has constant, I mean, it's not like we have 300 million prefixes in the database to show this off, but anyway, it's really fast. And what we're going to do is here, I'm going to increment a stat with each of the selected gateways, and we are going to be looking at how they balance together after we make the changes, or after you will downvote the lolsip gateway. And this CPS will let us know how many times this thing is spinning for. You will see just how many loops the OpenSIPS can do and how powerful the configuration language is, because it's almost as fast as C. It is one level above the C coding language. It's almost, if you write OpenSIPS script, you're literally writing C code. Right. I'm not sure if this clear AVPs function is something that I made up, because the do routing leaks memory, and if you call it multiple times, you will exhaust the shared memory pool. And there we will be using this event vote. If we go here, when we receive event vote from using Razvan's new addition in 3.1, the raise event externally, you can hook into the OpenSIPS configuration via MI, which is pretty cool. So basically, when you click in the browser, you will end up in this event route. Of course, I've made here a switch so I can turn things off. I can stop the voting. And this is kind of a limitation, so you don't spam too much. And this is where we set the MOS statistic that you provide through the submit form. And this timer route, which showcases that you can iterate through an entire group of statistics, will reset the statistics every 5 seconds, such that we get fresh data constantly and know how the routing is going. Because if I had kept them accumulating, we wouldn't have noticed your impact. Then this is also worth to note here, the MOS, that we need at least 10 samples of it in order for the thing to start working. So let's start this whole thing. It started, and let's watch it. I'm going to start one. I'm going to send one message. So we start the loop. I'm going to be using SIP. Okay, it got sent, and it's spinning right now. And it's like, if you can see, it's using up one of my CPUs fully. It's one process, like spinning like hell. If we look here, it's doing 132,000 calls of do routing per second. That is something. And if we take a look at the balancing, lolsip and funcom, they're receiving kind of the same amount of traffic. It's pretty cool, right? 200,000, 300,000, 62. This is the reset every 5 seconds, so we get fresh data, if you notice. And that's all there is to it. Okay, so people are already submitting stuff. Okay. I'm glad you're enjoying yourselves, because I wanted to ask you, I'm not sure. Anyway, I wanted to do this on 2 levels, right? First, so I'm going to stop the OpenSIPS. Let's do the demo properly. And I'll start it, and I'll stop. I'm not sure if I have the console here. Set vote. Okay, so this. 1 second. Okay, the voting should be stopped now. So because I knew this would happen, you would abuse of this.
We dosed
Yeah,
it. We dosed
yeah.
it. Yeah.
I didn't tell you to submit, but who cares, right? We'll click it, of course. So my request for you guys would be, let's punish lolsip just to the first level. It's not worth looking into the, or I guess there is so much time. Let me increase the font here. OpenSIPS. We can look in the QR profiles table. Oh my God. Yeah. Let's do /G. Maybe it's more readable this way. It's a lot better. Okay, so if you take a look here, for your custom statistics, you just have to add these 4 columns. So these are the default ones, ASR, or yeah, in the other order. There's a warning threshold and a critical threshold, and then there's the warning penalty and the critical penalty for all 5 stats. And for your custom ones, you just add each of these warning critical, warning critical. And in our case, we are issuing a warning, or we are reducing the traffic to half whenever we go below 4.15 MOS, right? Remember, the MOS is from 1 to 5. And we are really punishing the gateway. We're just reducing it to 5% traffic whenever it dips below 3 MOS. Maybe I'm not good with the MOS. Maybe 3 is beyond unacceptable. Maybe even 3.8 is a bad MOS. I have no idea. But let's just say 3. Right, so that was, let me close this console. That was my request for you, that the first submission round is with 4 value, right? And I'm going to be, let's just tail the OpenSIPS log, and let me clear it up a bit, and let's unleash, by the way, remember, we need 10 votes from 10 individual IPs, right? So in 2 seconds, I'm going to release the voting. You guys ready? 3, 2, 1. Okay, these are the votes flowing on the left side. Oh my God. Okay, these are a lot of votes, guys. So let's see. But if is it well, or I see a lot of, maybe something is not okay. I only see 2 IPs. Yeah, it might not be the smartest thing to use that ngrok public IP, right?
I think maybe you should purge the cache you have for the IPs, because
okay, it worked. It worked. It worked. Look, we just dipped. We don't have much time. Let me explain. We just dipped to 50% penalty, and if you can see the 2 values, it's half, right? 468 to 34. 553 to 56. It's really half of the above value. It's awesome. It is awesome. So the demo is working really fine. It's up until now. Right. What I'm going to do is I'm going to stop the voting. Okay. This is using the shared variables, and I have 1 minute now until the stats clear up, so we can talk a bit about this. You can do so many cool stuff with the SHV variables. You can program your script. You can do these external hooks. You can do a lot of stuff. For example, the vote switch. So right now the voting is off, and we have to wait 1 minute for the stats to clear, and they have already cleared. If you can see, they are back to 50-50. And the CPS, funny enough, because the shared memory has been stabilizing and the fragmentation has reached a point where things don't move around that much more, we are now doing 450,000 deroutings per second. Remember, we started with 150. So OpenSIPS, it starts in a way, but then it gets better. So remember that with OpenSIPS. And its allocators, right? It keeps getting a bit better after they warm up. Right, and now I'm going to kindly ask you to punish the gateway with the ugly punishment. So we're going to give it a 2 MOS. And yeah, let's do it. I'm going to re-enable the voting, and I'm going to do the max votes. So I give you 1 more vote. So now you get an extra vote. It's max votes 2 now. And let's see if this thing works or not. I'm a bit nervous about the unique IPs. It might not be the smartest thing.
It's Windows attacking you.
Yeah, I'm not sure if it's my IP or if that thing works. It's fine? Oh, okay. Then it's good.
Code testing on you.
It's okay.
I'm just clicking like crazy. Don't worry.
Yeah, so if you can, oh, right, I forgot about the YouTube lag. So we have 1 minute, right. So soon enough, we will start receiving votes with 2. And we should punish that gateway to okay. Oh, no, not yet. These are a lot of votes. Okay. I have a backup plan. So if this doesn't work, I'm going to send some curls locally. Okay. Maybe we can turn off maybe that thing. I've already voted. You know what? Let me give you guys a couple more votes. Now you have 4 votes. Okay, now you have 4,000 votes. Something is terribly wrong. I told you the demo gods. Why on earth? Max votes. Max votes. I'm just going to kill it. Okay. Let's just restart the whole thing. Okay, we watch it again and start the loop. And hopefully, all right, okay, good. So if we take a look, it's only receiving 1/5 of the traffic right now. It's like 1 million to 50,000 or 2 million to 10,000, 700,000 to 36. So it's only 1/20 of the other one. So that concludes the demo, guys. And thank you for all the help. You were amazing. This was awesome.
Nice job, everyone. Give yourselves a round of applause.
Awesome. I'm going to let you vote because it's, I'm not going to shut it down. Let's punish those LOLSIP guys because they deserve it. Awesome. The Ngrok guys are going to ban us because we are shipping so much traffic to them. Okay, so I guess that concludes the demo. Let me switch back to the slides. And thank you for all the help. And all you have to do now is go out there and play yourself with the queue routing module and let us know if it makes your life easier, if you can build cool services with it, and of course, if you can help us improve it. And yeah, thank you for your attention, and let me know if you have any questions.
Good job, Liviu.
Nice job, Liviu. Nice job.
Very good.
Nice
Very,
one.
very
Do we have any questions here?
Yeah, there are some questions. Jonathan asking, will this be shared within a cluster in the future, or so any plans when? If so, any plans when?
This is quite deep, actually. So we would have to cluster the derouting, right? There is a certain path to this approach because right now we are synchronizing the status of the gateways. So yeah, I guess we can, but I'm not sure. There are definitely not any plans right now, but we could start making some designs for this. Yeah.
All right. Another question from Jonathan. SQR profile stable columns customizable per custom metric.
Yes.
Yeah. Can we have multiple custom metrics?
Exactly. You can have as many of them as you want, and that was the whole thing, or how we designed the feature to allow you to put whatever stats you may find useful in there.
Okay.
I mean, we just made a stat that routes based on audience feedback. So yeah, yeah.
How do you conciliate cost and quality?
That is an excellent question, Flavio, because we've also wondered that by offering this queue routing, we are kind of making operators pick between one another, right? Do I choose cost or do I choose quality? So I don't have a good answer to that, really. You either pick one or the other. Yeah.
It's like an operations question here, and I
Yeah.
think I think it depends on the destination.
But I haven't thought whether you can merge these two together right now. Maybe there is some way to build like a statistic that gives you a bit of both cost but we haven't thought about it yet. Right now it's just one or the other. Yeah.
But like a parking goal to the algorithm.
Yes.
You can combine those values.
Mm-hmm.
On the same quality, choose the one that costs less. If there is one that costs very less, but has a quality that is not so different, choose that one. I mean, I think that you can calculate like 2 or 3 of this combination and then choose the best one.
Yeah, that sounds perfectly reasonable.
Cost as a statistic, right? I mean, it's basically the same thing, isn't it? And as long as this is how I say it, a high cost is basically should reduce the utilization of that gateway, whereas a lower cost should increase it.
That's true.
No, I don't think that will work. The idea with the cost, if you have it, you just build the LCR, right? You just build the gateway list, A, B, C, D, and failover, so you get the most money. Giovanni made a very good point. He said we route based on quality, right? So we get this dynamic thing that assesses the quality and changes, right? But if we have this to choose between 2 equal ones, we choose the cheapest one. So that sounds pretty good. I'm not sure if I see an immediate way.
You can also pre-calculate some other things. So, for example, on the same quality, you choose the cheapest one. But if the quality is different only by, let's say, 1 unit of MOS, and the differential is more in terms of cost is more than, let's say, 15%, then choose the other one. I mean, it's all, I mean, very plain arithmetic, and this can be implemented probably more in the script than in the module.
Yeah, one idea that I have sometime about quality routing is order by cost first and have some kind of penalty. If the gateway is below a certain threshold, put in the end of the line and the end of the row. Mm-hmm. Something. If it's below, add a penalty, and then put it at the end of the line for some time, like 1 hour, 2 hours, or until you have until the gateway is on the threshold, the minimum threshold to operate, something like that. Because it's very difficult to do it online, the ordering of the gateways, because it fluctuates a little bit. Another suggestion that I have for quality routing is there's something on the registrations now where you can get the latency of the registration. I don't know if it's on the net traversal or on the mid register.
It's in the user location or not.
Yeah. It would be interesting to get the statistics of latency on the gateways too, as you can probe. This is some feedback that you could insert on the on quality of routing.
I totally agree with that, Flavio. But if you have why do you have to measure yet another SIP thing, like how much it takes to do the options, when you get this whole feedback like PDD, or which one of them? Yeah, PDD. Won't that tell you how much it takes for you to route the SIP?
The PDD is more or less the time that you have to receive the first 180 or 183 or 200.
Yes.
It's not exactly latency. It's the time to complete the call. Let's suppose you have let's suppose a gateway using a R2 connection that it's usually slow, 7 seconds to receive the digits.
It's not the same thing. Yeah,
it's not the same thing.
Yes, because the 180 maybe comes from the endpoint, the final endpoint, right? Yeah. Whereas the latency, you just measure it with the gateway, correct?
Yeah.
So
we have something like a threshold for latency. Okay, put the gateway out after some threshold, because it's something very reliable in terms of when a gateway starts to get bad, the latency usually gets bad very quickly.
Something that, it's not, one thing's for sure, there's different points of view on how to do this, but this discussion's been all about the operator side, and what's being left out is the consumer side, or who you're selling to, because they're willing to, at a certain price point, they're willing to deal with a somewhat not good gateway, let's say, and that's how a lot of the providers, especially here in the US, will sell their packages. Okay, what do you want? High quality, high cost, or do you want low quality, low cost?
That's correct. I think your point of view is correct.
So determining what your customers' thresholds are on top of what your own makes it even more complex.
Oh, it's a business decision, I guess. There is some question from John Farmer. He is asking, can you limit deranking? Get away will receive never take less than 20% of the calls, for example.
Yeah, that's a good question. The direct answer is no, but I'm going to clarify what he's referring to. I told you that the penalties multiply together, right? So for example, if 3 statistics of 50% are multiplied together, that's like already only 12% of traffic. So Mark is saying, okay, can we have like a base limit so this multiplication doesn't make it 0? Yeah, and there is no limit right now. It can go to 0.
Yeah. Oh, cool. Well, a lot of questions. I guess, I don't know, you guys want to continue with this, or do you want to take it offline with Liviu? I actually have two notes on the presentation, which I wanted to inject. So if you don't mind.
That's abuse, Max. That's abuse. You're abusing your position.
Yeah, but once in a while. If you can go maybe to the slide 21.
So 1 second. So if we all agree, we can allocate like 10 more minutes. People can wait for their prices 10 more minutes, right?
Okay.
Wow. Executive decision.
Exactly. It's a business decision here.
We will win them anyway, so who cares?
Oh my God. Yeah.
What's the next show after us?
Raffle.
So Liviu, can you do slide 21?
Okay. 1 second. Present. Right here.
Yeah, 21, maybe 20, or yeah, 21 is okay. So I think what you're dealing here a little bit, and it also was mentioned on slide 30, particularly when you're talking about gateway going in and out kind of repeatedly. It's very important, and it's something we discovered probably a few years ago. I mean, 2010, maybe 11, 12. Whenever you happen to use like feedback mechanism to do some kind of dynamic control, I put a little driving here. Let's see if I can share it. That's my slide. Window.
Do you want me to turn off the sharing?
Oh, it will take over, I think.
Okay. Full abuse.
Yeah, sorry. So you have basically.
Wow, that is very technical.
So you have the situation which is called control loop. And that's basically what you're trying to do, right? So you basically have some kind of control mechanism which could do something. Let's say throttle the stuff up, and then you have some kind of measuring thing which controls the result and feeds back into control. It's a very known problem, and basically, if you implement it just like this, you always will end up with some kind of constant oscillations on the control channel, because there is a delay between you applying the control in here and then it taking effect in on this, and then there is some delay measuring it. So you will always be like playing catch up with that thing. Now how it's dealt in general is that you apply. Let me share. You basically apply filtering between your measuring apparatus and the control apparatus, which is basically. What's that?
Zoom in a little.
Zoom. Okay.
This is good.
So you basically apply. Oops, smaller. I'm just showing as a electric circuit, but it could be just an algorithm which removes like high frequency component from your feedback signal, and then what happens instead of that kind of always jumping up and down, you will end up with some initial kind of rollout when it settles, and then it basically finds the sweet spot which kind of balances it all.
Okay, this is awesome.
Yeah, I'll send you some links. Yes.
I have a question for you. Are my slides visible?
Not yet, but you can.
Not yet. Sure.
Oh, I have to. Sorry, let's resume. Blah blah blah.
Yes, once he wiped you out, he completely wiped you out.
Right. So if we go to how should I put this? The simple fact that we are not excluding the poor gateway out of the loop, doesn't it mean that we keep on getting the feedback out of it, and that as long as it doesn't go
no, but you're starting sending let's say let's go back to the simple scheme where you have one gateway, maybe that's slide number 30, when you have one gateway which kind of goes through cycles. I mean, the fact that not only you're measuring different amount of traffic, but also you're trying to kind of fix this gateway, right? Let's say it has some capacity limit which starts to kick in at some point. Yes. Every gateway does, right? Whatever limit that might be, it could be on signaling, or it could be on database, could be on network. Sooner or later, you'll hit this limit if you put enough traffic on it. So by the fact that you're applying this control and starting sending traffic elsewhere, you kind of fix it. So from being bad, it goes into good. Absolutely. So you're starting having this oscillation. So you basically.
I'm not, Maxim, I'm not advocating for this algorithm, by the way. This is why we didn't make it the default. but,
yeah,
I'm thinking maybe even with this one, right? Even with dynamic, it's the same thing, maybe.
It's the same thing. That's what I'm saying. Because
Yeah.
effectively you're removing load from that gateway, right? It could be removing completely, or you might remove like 50% of the load, and eventually it will.
And then it's fixed, right? So you go to the same cycle. Yeah.
Exactly. Yeah, that's one point. Another thing that I wanted to mention, I would really interested to look at your number lookup routines, and the reason for that, we built a little private module. We never really publish it anywhere, and we call it DNC daemon. And it's basically designed to take literally millions numbers and allow a very quick lookup among those numbers. And also it allows the reloading, the same thing that you mentioned. So I was curious if we could, maybe your algorithm is better than ours. Maybe ours is better. It would be interesting to see if we can share some.
I can answer that quickly for you. The derouting module is basically using a tree structure. It's not a tree, Alex, like the one you pick up peers from. It's a TRIE tree. Or I'm sorry, do I pronounce it poorly? Is it? I don't think it's try. I think it's tree.
No, you're doing good.
I've never heard of that word.
Yeah, I understand what you're talking about.
Yeah, tree. Yeah, so we're just using a tree, a huge tree. Yeah, like millions of hundreds of millions of prefixes, and the lookup time is constant.
Well, that would be interesting to compare. Like load the same amount into your code, into our code, and see what could be better. We don't mind releasing it as open source. It's just we never really saw any cool application for it outside of our domain. But so it seems like very interesting problem that people are working, and yeah, very interesting presentation in general.
I'm glad you liked it.
Sounds like he wants to race you, man.
Like everyone.
Yeah, it was great. I'm happy the demo went well.
We do have some more questions, but we are about 10 minutes over.
Yeah.
So in order to continue in either direction, we're going to need another executive decision.